Hello everyone. Today let's solve the problem number 45, jump game 2, right? So let's see what the question states here. So we are given an array nums where nums of I, see here we are given an array nums here where nums of I is the max jump length from the index I. From the index I, it is the max jump. See here, this we can jump 2 steps, we can jump 3 steps, we can jump 1 step, we can jump 1 step, and we can jump 4 steps, right? So now starting at the index 0, meaning here we have to start from the index 0, this one number, value 2 they have given, right? So we have to start at the index 0 and return the minimum number of jumps to reach the index n minus 1. So we have to go, this time we have to go with the minimum jumps, right? So minimum jumps that is required to reach the index n minus 1, right? So minimum jumps that is required to reach the index n minus 1, right? So this is fine, man. uh, we have to start at index 0 and return the minimum number of jumps to reach the index n minus 1, right? So it is guaranteed that the last index is reachable. So this time the only difference here between the jump game 1 and jump game 2 is that we are starting at the index 0, no doubt, and we are returning the minimum number of jumps to reach the we have to return the minimum number of jumps to reach the index n minus 1. That is the only difference, right? So it is guaranteed that the last index is reachable, right? So this is fine. Now, so see here, the input that we have here is this one, nums 2 3 1 1 4. This is fine. Now the minimum number of jumps to reach the last index is 2, right? So how it is 2? So we will jump 2 steps from here, right? So this will be 3 basically. Now we will jump 1 step to here, right? So from 1 step, finally we will jump from this one to this one, 3 steps, 1 step, and then finally 3 steps, right? So jump 1 step from index 0 to index 1, then 3 steps to the last index. So that's what they have given here. From 1 step, nothing but we can either, so whenever they have given value 2 3 1 1 4 here, so we can either jump 1 or 2. I here for 3 we can either go with we can jump 1 2 or 3 steps. For 1 we have to jump 1, for 1 again we have to jump only 1. For 4 we can jump 4 steps, right? So this is the last one, we don't have to consider this one. This is fine. Now let's consider example 2 here. Again, so we can jump, again we can jump 1 step here, again from we can jump 1 step and then take this one, 3 jumps, right? So then we can take 3 jumps which will lead to the last index 4, right? So this is fine. Again, 2 jumps are necessary here, 2 jumps are necessary here, accordingly with the value, 1 jump and then 3 jumps. So overall 2 jumps, right? So this one jump, and then again another jump, means 3 jumps basically. So what we need to we need to return the minimum number of jumps, right? So 1 jump and 3 to reach the last index. So overall 2 jumps, right? So don't get confused here. So this is fine. So they have given us wonderful examples just for the sake of understanding them. Now let's do one thing. Let's quickly discuss the approach basically, right? So let's consider the same first example here. We have 2 3 1 1 4, right? So we will start when I equals 0, far equals 0, end equals 0, and jumps equals 0. So these are the 4 things that we'll be going with, far, end, jumps, as well as the I. So at I equals 0, far will be max of 0 comma 0 plus 2, right? So previously we had went something similar to this one. Far equals this one, m is nothing but the max, don't get confused here, max of current, this one, and max, this one, current index plus the value, right? So this is fine. Now we got the value 2, right? So since I is equivalent to end, we have reached the current window end, so we must make a jump. So we will jump will be 1 and end will be this one, end will be equivalent to far, that is equal to 2 basically, right? So jump will be 1 and end will be equivalent to far, that is equivalent to the 2, this value, right? So this is fine. Now this is for I equals 0, right? So now let's go with I equals 1 iteration. I when I equals 1, so far will be again it will be max of this time to previous value, this one, right? So this one or far this one far value, whatever we got here, this one max of to previous value comma present index is 1 plus the value of that first index, value of the first index we have got 3 here, so this one will be 3, right? So this one will be 1 2 comma 4, 4 will be the maximum, right? So now we have got 4, we discovered we can reach the index 4. So index 4 is the last one. So we have all now we have discovered that we can reach the index 4. Right, right. So this we will conclude for I equals 1. Now let's go with I equals 2. 2, right? So we will go with far off. Again, same thing. So this one will be max of previous value we got 4 and index will be 2 plus index value will be quite obviously 1 we have here. See, 1 we have, right? So this one will be 1. So here for this particular step I is equivalent to the end, so this one 4 we will get, maximum of 4 and 3 will be 4 itself, right? So now I equals end, again 2 will be equivalent to 2, so we will make another jump, jumps will be 2 and end will be, so jumps will be 2 basically, and end is equivalent to far, sorry, this one equals is enough, man. Yeah, end equals far equals this one, what do we call, 4 basically, end equals far equals 4, which reaches the last index, which reaches the last index. What we will do, we will stop and return 2, we will stop and return 2. uh, Jumps we have got 2 here at the end, right? So we will stop and return 2 basically. So now whatever the output that we got here is 2, which is equivalent to the output that they have mentioned for the example 1 within the question. Simple, man, right? So I have showed you the 3 iterations now accordingly, right? So we can reach the index, this one, fourth index with the value 4. So the jumps we have here is 2, right? So jumps we have here is 2 and end equals far this one we have got 4. This is fine, meaning that we can reach the index 4, right? So approach that we went with here is greedy, right? So first itself I had to mention this one, I forgot basically, we went with a greedy approach basically, right? So this will be with the approach that will be going basically, finally we'll stop and we will return to, right? So what we did here, we greedily extend the reachable window and only increment jumps when we exhaust the current window. That's what we did here. So this greedy approach works absolutely correct for the this one, for this particular problem, right? It's simple and effective to this one implement. So this is fine, now we are done with this part. Now let's do one thing. As we are completely familiar with the approach, let's quickly discuss the complexities, man. So what will be the time complexity and the space complexity here? The time complexity would be big of n and the space complexity would be big of 1. So we are going with the greedy, right? So this one time complexity is big of n because as usual greedy single pass will be going with a single pass through the array, updating this one far as well as end, as I showed in the approach, right? So this is fine. Now, why it is big of 1 space complexity? So we'll be making use of only few integer variables and no extra arrays will be used. So overall space complexity would be this one. What do we call? Big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively. Now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So first we'll be making use of the number of positions, or let's get the length once more, right? So I'll just go with int n equals nums dot length. This is fine. uh, Now let's go with the trivial case. So nothing but when we are already at the last index, right? So this is when n is less than or equal to 1, right? In that case we have to return 0, zeroth index. So in that case we have to return 0, right? So 0 jumps, so no jumps needed if there is a single element, right? So that's what I wanted to say. This is fine. Now let's initialize this one, jumps end as well as far, right? So jump is nothing but the count of jumps taken, end is nothing but the end of the current jump, this one minus range, as well as far is nothing but farthest index that is reachable within the current window, right? So let's quickly write this one, int jumps equals 0, along with int end equals 0, uh, along with this one int far equals 0. This is fine. Now let's iterate until the second last index, meaning we don't need to jump from the last index. So I'll just go with for int I equals 0, I less than n minus 1. So this one will be I plus plus. So this is fine. Within the for loop, what we'll be doing, we will be updating the farthest reachable index from positions seen so far. So I'll just go with far equals math dot max of this one will be far comma I plus nums of I. This is fine. Yep. This is nothing but far equals max of far comma I plus nums of I. So this itself, with this formula itself we went right. So we discussed in the approach basically. Maximum of far is nothing but the end equals far equals the value that we got. Basically initially we'll be going with a 0, then whatever the value previously that we got, so that we'll be going with, right? So we will be updating the farthest reachable index from the position uh, that is seen so far, that has been seen so far. This is fine. Now let's do one thing. When we reach the current window end, we must make a jump, meaning if I equals end, then within the if condition, um, this one, we have to perform a jump, in the sense we have to increase the count, right? So I'll just go with jumps plus plus. Next, we have to set the new window into the farthest reachable, nothing but end equals far. This is this we know accordingly with the approach. So one more thing. So this one, this is optional, nothing but optional early stop. So if we can already reach the last index, then we have to break, right? So let me write this one as well, or else it will not work. So this one, if end is greater than or equal to n minus 1, then let's break. This is fine. Yep. Let me come out of this one entirely. Finally, what we'll do, we'll be going with a minimum number of jumps to reach the n minus 1. So this will be return jumps. So this is fine. So we're done with the coding part, right? So let me format the code once and let me hit the run button. We have ENS. Where is it? Line number 17. So what is this one? This has to be end, man. Yeah, this is fine. Now we have to get the now the test cases has to pass. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases. Let's see. So all the test cases are getting passed. Once the code works absolutely correct in this case, right? I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.